All right, we have the overview video for the articulated Cartesian arms. As far as I'm aware, these are the industry first. I've scoured the globe and the web to try to find out how to do this, and I haven't found anything. So if someone can do this, cool, props to you. I have a special guest with me, Don Rasmussen from CAD Technology Center. Say hi, Don.
Hello, everyone.
Thanks, Don. We're going to be talking about the arms. There is so much potential for these arms, and really I'm relying on you guys, the users, designers, engineers, contractors, to figure out how else we can use these, not to mention manufacturers. So what these arms are is they're pinned to a given reference point in a family, and they can move around. And their main purpose is to host something. So in this case, this is our plumbing fixture configurator, which we're going to be talking more about later on in the user manual. But as you can see, we have a round connector, and we are hosting our connector to the end of it. So as you guys will see, what this will allow us to do is to move this connector wherever we need to. No limits, no reference planes, positive, negative values, whatever you want to do. So let's go and look at the family itself, just one of these arms. All right, so here's one of these arms. In the cloud model, or in the MEPPP model, in most cases these heads are visible. These heads represent duct connections, pipe connections, everything like that, even electrical connections and clearance attachments. So in most cases these heads are visible, and these arms are not. So the arms are the magic behind everything, and you won't see them in the project. So that's what this video is about. So I would encourage you to thoroughly go through the user manual, because we outline how they function, how the coordinate system works, and everything like that. I'm just going to try to run through a handful of situations in moving these around. So in this case right now, this arm is pinned to the center of the family, and that is our XY coordinate system. So when you see these center front to back and center to left and right reference planes, that essentially is the center of this family that all the coordinates are based off of. So let's open up our type properties, and let's move this around. All right, so like I said, it operates off of the Cartesian coordinate system. So the user manual does a really good job of showing you guys exactly what that means. But the Cartesian coordinate system has an x-axis, a y-axis, and a z-axis, and you start moving from this point. So this is positive x, this is positive y, quadrant 2 is positive y, negative x, and so on down the line. Same for rotations. You're always starting from this x positive axis in the Cartesian coordinate system. So right now we have the head that's holding the connector in the other family at 1 foot, 1 foot, 2 foot. So let's move it around. Let's make the y value 2 feet. So once again, positive y value, moving that way. Now let's go with a negative y value, negative 6 inches. Let's stay with the positive y, and let's change the z to 1 foot. And as you guys can see, we're moving around the Cartesian coordinate system. This quadrant down here would be negative x, negative y values. So if this was negative, and say we also have a negative z value, let's go negative 1. So there we go. Now this head in this family is constantly updating itself to maintain the front of the family, which is this face. So front, right, back, left. I didn't make this up at all. This is right from the view cube. Let's go to corner here. So there we go. That's where my names came from, right from Autodesk. Top, front, right, back, left. So in case you guys are wondering. So now what we've done is this head is constantly staying aligned with the front of the family, so that when a given user comes in here and says, hey, I want my connector on the right face, the right is always the right. You know, or if they said, I want the left face, they could choose left face, you know, and the head rotates around. It's not actually flipping, it's rotating. So let's go back to a standard position. Now let's say we have like a storage tank where we want to rotate around a given family by a radius and a degree, a theta angle. So we can change the connector to use polar coordinates. So when this is checked, now the inputs switch to using polar rotation R, length, and an angle. So we could say, let's go 2 feet out at 30 degrees. And there we go. We're 2 feet out, the radius, and we've rotated 30 degrees here. So now for the case of this round family, this tank type family, maybe we want the connector to be squared up here. So we added functionality to turn off the head from aligning it to the front always. So alignment to front, we're going to turn off here. It's in dimensions. And now at this point, the head will rotate around with the arm. So now if we choose right face is going to be, you know, perpendicular to the arm at that point. So we can rotate all the way around. We can go 3 feet. Let's go 679 degrees. And there we go. So 360 around, and then whatever's remaining, and I'm not doing the math. So that's the polar coordinate system. You know, and I guess we didn't stop there. So Sean Zerbies, he's like, well, you know, what if we want the head to be on the outside or the inside of a family? Well, we got that functionality too. So you can check that box. You can flip the side that the head is on, depending upon what type of family you're going to build. And then now we also, if that wasn't enough, we included overrides for everything. So if some user in a given family has chosen, let's go back to X, Y, and Z coordinates. So let's uncheck use polar. I could zero these out, but I don't need to because they're not being used. Let's go back to a more conventional visibility state. So 2 feet above, let's hit apply. Oh, and we want the head to auto align to the front. So now right is right. So what we've done is we've built in overrides. So if you wanted to override however this is set up, you know, you can just start entering values. So now we're rotating around with an override value, and even in the vertical we can override as well. So we can override that, and now you can truly see that this arm can hit any position possible in a given family. So whatever angle, I'd encourage a manufacturer to get a hold of me and try to give me a situation that the arm can't get to, and that's my challenge. So there you go. We have visibility control for the pin and for the host. Like I said, in most cases the host is visible. So let's go back to the family. I just want to show real quick what the how the overrides are used in our package. Let's close this. So this is the plumbing fixture configurator, sorry. So this has been used to build all of our plumbing fixtures. So every user, whatever family they go into, they can move these arms around and they're all going to have the same parameters. And what this has is this basically has a set of construction, yes/no parameters to build the family however you want. So this is a 3-compartment sink. But let's say let's make something else. So let's make a gas So this is going to be a connection for a gas dryer. So we can uncheck the arms that we don't want. And now those overrides, the whole purpose of this is to show that, so yes, Revit's going to say there's identical instances in the same place. That's just fine. And we're left with just our gas connector. So now we could edit the dimensions for that. So let's just filter this list by gas. So we can control the depth. We can do whatever we want. So let's make that 2 feet. Let's make this 2 inches. And right now it's at an X of 0, a Y of -6. So let's go, just where we were at in that other family, 1 foot, 2 foot, 3 foot. And let's put the connector on the front face of the family. There's our gas connector right there. So that's the power of those overrides, being able to use formulas to drive the values regardless of what's chosen, here for those connectors. So this is truly just the beginning of this discussion on the articulated Cartesian arm. I'd love to hear what you guys are doing with it. We'll talk more.